social medias. So this is a record. Now, my background is not that great, but anyway, yes, I'm sitting in the kitchen, it's open plan, and I hope you will be very curious to know what is epigenetics and what is nutrigenomics and why these two words we have been hearing all the time from medical research, from nutritionists, from integrative doctors. So before I start, I would just like to explain what is epigenetics and what is nutrigenomics. And I believe that many of you already have some understanding of epigenetics and nutrigenomics. So the epigenetics is actually a study of heritable changes in gene function. And these heritable changes, they do not involve changes in DNA sequence. You know what is DNA sequence and DNA function, genetic function. And nutrigenomic, it's actually an exploration of the interaction between nutrients and genes and how this affects our health. So for your understanding, people who practice nutrigenomics, they do not need to be geneticists to actually explain to you and to understand how epigenetic factors influence your gene functions. Because DNA expression is one thing and DNA sequencing is a different thing. DNA sequencing is something we get through, it's our heritage. Something like fibrosis or sickle cell disease, something like this, we would call DNA sequencing related. But something like diabetes and, insulin resistance, autism, ADHD, things like that, autoimmune conditions, they are epigenetic related, right? So we can say that genes are the hardware, and epigenetic and our environment, that's what epigenetics is a software. And this software influences how the hardware operates. Excuse me. So the key epigenetic mechanisms are mainly histone modification, non-coding RNA, and of course DNA methylation. So we will be talking mostly about DNA methylation, and I will explain to you what DNA methylation is and how it is related to our gene function. Because methylation is the word which is used pretty much in every posts of integrative practitioners and even biohackers. So methylation is something you need to know about, and you need to know how do you methylate, because once you know that, you are armed for the rest of your life, because you will know the secret key to your gene function and to your methylation, which is absolutely important for the detoxification and for all our body organs. So what are the influencing factors? What is related to epigenetics, and what do we call epigenetics actually? So epigenetics are few factors. And first factor, I would say, as a nutritionist, is a diet, is what we eat on everyday basis. And here we are talking about foods which are genetically modified, foods which are non-organic, foods which are grown in a depleted soil, and foods which are processed. So all these foods, they actually affect our epigenetic marks, and therefore they affect our genetic function. So the second factor is physical activity. So because it's not news that people who are physically active, they usually live longer and stay more active. Because physical activity such as regular exercise, they influence our gene expression, which is related to metabolism and inflammation. So under exercising is bad for you, and over exercising is not good for you either. So you really have to have that balance, and it's all depends on your genes. And this is why when you know how you methylate, you actually can adjust your lifestyle to your genes. So the other factor which is related to epigenetics is environmental exposures, and here we are talking about pollutants which surround us and toxins which we inhale, so heavy metals, mycotoxins, exhausts, and the cigarette smoke, and all these things which we cannot control, unfortunately also can change our influence our gene functions. So, and the last but not least, very important, and I think the most widely spread factor is stress. If we can control what we eat, and we can control our physical activity, and pretty much we can control environmental exposures, because if we are tired of all these exposures we are facing every day, we can move to a different place where it's more kind of clean. But stress, yes, we can control, but we can control chronic stress only when we understand that we are chronically stressed. Because nowadays, not many people actually know that they're chronically stressed. And our lifestyle is built in such a way that we are used to living a hectic life, used to do 100 things at a time, at the time. And that's how we live without understanding that this actually causes chronic stress. Uh, well, some people who have been to retreats, for example, and for like 7, 10 days retreats, and who got to that state of pure 100% relaxation, they do understand what it is to be chronically stressed, because they have something to compare it with. But some people have never been to 7, 10 days retreat to actually give themselves a chance to understand what their normal state should be like. This is why for many people, chronic stress is a normal condition. The recent research study, which is published in BMC Medicine, it's found that following the vegan diet for 2 months can actually significantly reduce biological age. And if you are a vegan, and if you have sufficient iron and vitamin B12 in your body, if you're actually following your biomarkers to support your health, that means you will be living longer and healthier life. So congratulations. Now we're going to be talking about the connection between epigenetics and gene expression. As I mentioned before, that yes, certain factors which are exposed on a regular basis too can change our genetic expression. And when we are talking about genetic expression, because some genes we're born with are down-regulated and others are up-regulated. Not all of the genes have up and down regulations, but some of them, they actually are too slow or too fast. The ones which are too slow can be a wild type, which are absolutely, you know, optimal and working up to 90% of its capacity, but they can also be homozygous or heterozygous, which means that heterozygous when you get one bad gene from one of your parents, and homozygous when you get two bad genes from both of your parents. So these genes, when they're downregulated, they're not only working to up to 40% of its capacity, but they're also working very slow. So if you're born with this kind of genes, that means by the age of 30, 40, if you're constantly exposed to that epigenetics triggers, you're going to experience symptoms. This is why they say after 40, all the symptoms are starting to show up. We feel how we age. We feel how we age only if we living life without kind of filtering what we eat, what we experience, what we breathe, and so on. And we have polymorphisms as well. Some people who are armed with the knowledge of their DNA expressions, they can actually regulate and they can modify their symptoms and their health. So, and this is the when we are talking about the connection between the epigenetics and gene expression. Sorry, I think it's either my screen is going dark or my eyes are going blind. Here's epigenetics to you. Okay, that's much better. So dynamic gene regulation, that means that epigenetic modifications, they can activate or silence genes in response to environmental cues. So what does it mean? So if we are exposed to poor quality air every day, and this air happen to have a lot of heavy metals, and you have a very poor detoxification genes, which are in your liver and responsible for detoxifying heavy metals, they can, of course, modify your genetic expression and speed up that poor functioning genes, which would work even poorer by the age of 30. But if you have a very good detoxification gene and if you are breathing clean air, so this epigenetic modification will actually support your gene function. It will not slow it down or it will not speed it up. It actually is going to support your genetic function. So, what are the health implications of a constant exposure to your epigenetic? The constant exposure to poor epigenetic factors is actually cancer, which can be also sorry, it can be cancer. We can protect ourselves from developing cancer, and especially if we know that we are genetically predisposed to cancer. And it can also be a metabolic disorders, because epigenetic changes, they influence genes which are involved in insulin sensitivity and fat storage as well. So this is how we can actually regulate our gene expression through regulating epigenetic factors. So recent research showed that comprehensive review that dietary polyphenols, and there is a lot of polyphenols in purple berries, in olive oil, they play a significant role in the prevention of various cancers through epigenetic mechanisms. So what does it mean? This is where nutrigenomics comes to place. So nutrigenomics, this is a beautiful branch of genetics which actually tells us how nutrients can support, downregulate or upregulate the expression of our genes. So supplements such as omega-3, for example, they modulate genes involved in inflammation, as we all know, and also in brain function. Curcumin as well, it actually affects and influences gene expression, which are involved in not only inflammation, but also detoxification. Sulforaphane is actually very strong supplement, and this is the broccoli related antioxidant, because sulforaphane is in broccoli sprouts, and broccoli sprouts are the richest sources of sulforaphane, and it helps our detoxification process. So here, that's why we need personalized nutrition. That's why we need nutrigenomics for us nutritionists to understand what genes do you have poorly functioning and what we need to give you as a supplement in which dose to actually support this gene. Because if you have a poor sulfonation, which is a part of your detoxification process, then we will definitely give you sulforaphane. If you have a poor glucuronidation, then we have to give you calcium deglucarate, because all the stages of detoxification, they are related to heavy metals, to mycotoxins, to extra estrogen in your body, and so on. So this is why we need tailored, individualized nutrition, and this is why you need your nutrigenomic test. So there also has been a recent research, and there have been clinical trials which suggest that healthy dietary patterns are associated with beneficial effects on DNA methylation. And I was talking about methylation in the beginning, and now I will come back to methylation to give you a little bit more overview about methylation. So methylation is actually affects our aging process, and this process of methylation is that bridge between the environment and between our genes. Through methylation, our genetic function is affected uh, by epigenetics. So that's why methylation is important, because that's the only bridge we have which actually connects our genes and our environment. So, genes expressions and how does it affect our health? So beyond genetic predisposition, we also have a lifestyle choices, which I already mentioned to you. And these lifestyle choices can modulate gene expression, mitigating genetic risks. Examples, for example, is the well-known gene, which is called MTHFR, methyl tetrahydra folate reductase. So this gene MTHFR is important to support the whole methylation process. Why folate or folic acid, which is the artificial form of folate, is important when, especially when you're pregnant, because it's not only helps your baby to develop when you're pregnant, but it also helps your methylation process. That means detoxification process, right? So, and when you take folic acid, it's understandable why many doctors prescribe folic acid, because folic acid is absorbed in our tissues no matter what. So this is why it is very easy to get folic acid. What is it called? Not deficiency, but extra folic acid. Give me the word, guys. Not deficiency, but when you have too much of it. Uh, ex, um, Excess. Thank you, Lorette. So this is why folic acid, when you have this folic acid in your body, depending on how you methylate folates, yeah, it will depend how much of this extra folic acid you will build in your body. And when you have a lot of folic acid in your body, you are predisposed to the symptoms. You will develop the symptoms which are really similar to the symptoms of B12 deficiency. So this is why folic acid, integrative doctors, they do not prescribe folic acid anymore, because this is dangerous, and folic acid is pretty much everywhere. We have so much fortified foods, and in 75, I think this law in US was accepted to actually start fortifying foods to prevent that a neuronal tube defect the children were born with at the time. So this is why since then, no one actually reviewed that law. And nowadays, there are so many different products which are fortified with folic acid. And if you, I don't even know how many of you know how you methylate, but in any case, folic acid is not suggestible in high doses and or for a long time. When it comes to folate, the natural folate, which is in green leafy vegetables mainly, folate is very sensitive to different factors such as alcohol. And if you eat a salad and drink wine, so that folate in the green leafy vegetables will be hardly absorbed. And especially if you have a polymorphism on folate receptor, it will not be absorbed exactly. So this is why, in order for us to supplement ourselves with vitamin B9 or folate, we always prescribe methylfolate. And methyl comes from the methylation process, because this folate has been methylated. So that means it has been activated to absorb in your tissues in your body and to actually support the mechanisms, other mechanisms of methylation. And these mechanisms are, I don't know, homocysteine recycling. When you have high homocysteine, that means that you have a poor methylation, because vitamin B9 is a key of methylation. And the second key of methylation is vitamin B12. And there are other keys and supplementary cofactors which help the methylation process, such as potassium, magnesium, zinc, choline, betaine. There are so many of them. And you really need to know how you methylate to age well, to stay active, and to stay healthy until you die, really. So MTHFR is one of the genes which are absolutely essential for the methylation, for the genetic factors which predispose us to aging. And also there is one other gene which is, there are so many genes, but two main genes I want to highlight is MTHFR, and another one is APOE gene. And this one is actually giving us a clue whether you're predisposed to Alzheimer's. But a very good clue whether your relatives had any Alzheimer's, if you have it in your family. But when you want to test yourself whether you are predisposed to Alzheimer's, you're going to test again genetic testing to test yourself for APOE gene. And if you have APOE type 4, that means you're predisposed to Alzheimer's, and you really need to take action. By the age of 50, you need to already start taking certain supplements and certain hormones, such as estrogen, to prevent Alzheimer's disease. So, and there was another recent study indicated that high intake of added sugars may accelerate biological aging by inducing oxidative stress and inflammation. And this is evidenced by DNA methylation patterns. So DNA methylation is not only detoxification. This is support of your iron production. This is support of your gut health. This is support of your dopamine production, of your melatonin production, of your adrenaline production. This is support of your estrogen detoxification. This is support of glutathione production. This is support of the mitochondria production. I mean, you name it. Methylation is actually there to support our whole body. So what is actually methylation? And methylation is the addition of a methyl donor. Methyl donor is a carbon group, is actually biochemistry already, and the carbon group is CH3. When you have folate entering our body, this folate is naked. This is not bioavailable folate. And this folate needs to go through the methylation process to actually gain this methyl group to be a little bit more active. Not a little bit, but much more active. So this is why we need that methyl group to function, to be added to different enzymes and proteins to be more active, to get well absorbed by our body and well synthesized. So a role in health, as I said, detoxification, neurotransmitter production, DNA repair, and so on. And also nutrient support, as I said already, is folate and B vitamins, B6, B3, B2, you name it. That's why when we take B vitamins, we want to take B complex vitamins. Usually in B complex vitamins, there is already high dose of vitamin B9, high enough dose of vitamin B12, but of course it depends on your condition, because if you have B12 deficiency, of course there should be more B12 than B9. There are different multivitamins or B complex vitamins you need to choose from, and it's better to talk to your nutritionist or integrative doctor. So, and of course there is choline, and choline is one of those cofactors which help us recycle homocysteine back to methionine to actually prevent the buildup of homocysteine, because homocysteine, when it's high, it might cause cardiovascular condition, inflammation, and so on. So choline is one of those cofactors which support homocysteine recycling without methylation. Okay, so it can actually not depend on vitamin B12, which goes and helps to recycle homocysteine, but it goes straight recycling homocysteine to methionine. Okay, so how methylation links epigenetic and genomics? As I said, it's the only bridge between the environmental factors and genetic expression. So disease prevention, such as cancer and cardiovascular diseases, are directly related to the epigenetic regulation and methylation. And also, dietary components can reverse abnormal methylation patterns, reactivating tumor suppressor genes. So, again, your methylation is very essential to prevent cancer. And methylation status of specific genes influences heart disease risk as well. There was a comprehensive review discussed how nutrigenomics and epigenetics play a role in cancer prevention, highlighting the impact of diet and gene expression. So, what else did I forget to mention? Let me see. Yeah, folate, B12, B6, that we know. Sleep, future of epigenetic DNA methylation testing. So, for now, that's pretty much it. And if you have any questions, guys, shoot it and I will try to answer it. So, I think that was a successful stream on my um, social media. I'm going to end this. Um, yes.